What was there before the Big Bang? It is probably the most natural question anyone can ask about the origin of the universe. Something happened 13.8 billion years ago. Something unimaginably hot and dense exploded into existence and became everything we see. So what was there before it happened? What existed before the beginning? Here is the problem. That question might not make sense, and understanding why it might not make sense is, I think, more disturbing than any answer could be. The Big Bang was not an explosion that happened somewhere in space. It was not a bomb going off in an empty room. There was no room. There was no empty. The Big Bang was the beginning of space itself, and according to Einstein's general relativity, it was also the beginning of time. Space and time are not separate things. They are woven together into a single fabric called space-time, and that fabric came into existence with the Big Bang. Asking what happened before the Big Bang is like asking what is north of the North Pole. You can say the words, the grammar is correct, but the question has no answer because north ceases to exist at the North Pole, and time, in the classical model, ceases to exist at the Big Bang. I want to sit with that for a moment because I think most people hear it and move on without really letting it land. There was no before, not an empty before, not a dark before, not a silent before. No before at all. Time itself did not exist. The moment of the Big Bang was not the first moment in a long sequence. It was the first moment, period. The sequence starts there. There is nothing behind it. Not nothing as in empty space. Nothing as in the absence of the concept of nothing. And I will be honest, every time I try to think about this clearly, my brain crashes. It is not that the idea is too complicated, it is that the idea requires me to abandon a framework I have used every second of my life. I have always lived inside time. Every thought I have ever had has occurred in a sequence, one after another. The idea that sequence itself has a boundary, that there is a point beyond which there is no earlier, is not just strange, it is alien. It is the kind of thought that makes me feel like my mind was not built for the universe it inhabits. But here's where it gets truly interesting, because that classical picture, the one where time starts at the Big Bang and there is nothing before it, might be wrong. In the early 1980s, a physicist named Alan Guth proposed a radical idea. He suggested that the Big Bang was not the beginning. It was a transition. Something existed before the hot, dense state we call the Big Bang, and that something was cosmic inflation. Imagine the universe before the Big Bang. Not hot, not dense, not full of matter and radiation. The opposite. Almost completely empty. Almost at absolute zero. Nothing but empty space. But that empty space contained energy. A strange, exotic form of energy embedded in the vacuum itself. And that energy caused space to expand at a rate that defies comprehension. During inflation, the universe doubled in size roughly every 10 to the minus 37 seconds. That is a decimal point followed by 36 zeros and then a 1. In a fraction of a second shorter than any human concept of time, the universe grew by a factor of at least 10 to the 26th. A region smaller than an atom expanded to become larger than the entire observable universe we see today. To put this in perspective, imagine you had a grain of sand. Now imagine that grain of sand doubling in size, then doubling again and again. After 80 doublings, that grain of sand would be larger than the observable universe. 80 doublings. That is all it takes to go from the unimaginably small to the unimaginably large. And inflation did this in a time interval so short that light could not travel across a single proton. Everything we see, every galaxy, every star, every planet, every atom in your body was once contained in a region smaller than an atom, and inflation stretched it into a cosmos. That is not a metaphor, that is what the mathematics says. And the mathematics is supported by every observation we have made of the cosmic microwave background. And when inflation ended, all of that vacuum energy had to go somewhere. It transformed, it converted into matter and radiation, flooding space with a superhot plasma at trillions of degrees. That plasma was the Big Bang. The Big Bang was not the creation of the universe. It was the moment when inflation stopped and its energy was released. It was a consequence, not a cause. I find this one of the most beautiful ideas in all of science. The universe was not born in fire, it was born in ice. Cold, empty, featureless space stretching itself exponentially, and then suddenly dumping all that energy into heat and light and matter. The fire came second, the silence came first. But this raises an obvious question. If inflation came before the Big Bang, what came before inflation? What started it? And here is the answer that keeps physicists up at night. We do not know, and we might never know. Because inflation is, as physicist Will Kinney puts it, a cosmic eraser. The exponential expansion of inflation dilutes and smooths out everything that came before it. Any structure, any information, any trace of whatever conditions existed before inflation gets stretched to nothing. Inflation does not just precede the Big Bang, it destroys the evidence of its own origins. Whatever started inflation, inflation itself makes sure we cannot find out. This is deeply unsettling to me personally, not because the answer is unknown, but because it might be unknowable by design. The universe is not just hiding its origins from us the way a crime scene might be cleaned. It is hiding them in a way that is built into the physics. The very mechanism that created the conditions for our existence also erased the evidence of what created it. It is as if the universe is saying, you get to exist, but you do not get to know why. Now, even though inflation erases what came before it, physicists have not stopped theorizing, and the theories for what might have preceded inflation are some of the strangest ideas in all of science. The first and most widely discussed is eternal inflation. This idea, first proposed by Paul Steinhardt in 1983 and developed by Alexander Vilenkin and Alan Guth, suggests that inflation did not happen just once. It is happening right now. It has always been happening, and it will never stop. Here's how it works. In our region of the universe, inflation ended 13.8 billion years ago, when the vacuum energy decayed and converted into the hot plasma of the Big Bang. But in the region surrounding our bubble, inflation never stopped. Space there is still inflating, still expanding exponentially, still stretching faster than the speed of light. And within that inflating space, quantum fluctuations occasionally cause the vacuum energy to decay again, creating new bubble universes. Each bubble gets its own Big Bang. Each one expands and cools and forms its own stars and galaxies. Each one is a complete, self-contained cosmos. And the inflating space between the bubbles grows so fast that the bubbles can never touch each other. They are separated not just by distance, but by the expansion of space itself. Even if you traveled at the speed of light for eternity, you could never reach the next bubble. This is the multiverse, not science fiction, not philosophy, a direct mathematical consequence of the most successful theory of the early universe we have. If inflation is correct, and all observational evidence currently supports it, then the multiverse is almost unavoidable. Our universe is one bubble in an infinite, eternally inflating foam. And here is what makes it even stranger. Each bubble universe might have different physical constants, different values for the strength of gravity, the mass of the electron, the speed of light. The laws of physics as we know them might be local bylaws specific to our bubble, while other bubbles operate under entirely different rules. Some might have no atoms, some might have no stars, some might collapse back into nothing a fraction of a second after forming, and some, by sheer chance, might have constants tuned just right for complexity, for chemistry, for life. We would naturally find ourselves in one of those, because we could not exist in any other. This is called the anthropic principle, and it is one of the most controversial ideas in modern physics. Some physicists find it elegant, others find it a surrender, an admission that we cannot explain why the constants have the values they do, so we invoke an infinite number of universes and say we happen to live in a lucky one. I find myself somewhere in between. It is not a satisfying answer, but the universe is under no obligation to give us satisfying answers. And the personal opinion I cannot escape is this: if the multiverse is real, then the question of what came before the Big Bang has a very simple answer: more universe. Our Big Bang was not the beginning of everything, it was a local event, a phase transition in one small region of an eternally inflating space. Before our Big Bang there was inflation. Before that inflation there was more inflation. Before that, more still. The chain might not have a beginning at all. But not everyone agrees, and the competing theories are equally fascinating. One alternative is the bouncing universe. In this model, the Big Bang was not a creation from nothing or a transition from inflation. It was a bounce. The universe existed before in a contracting phase, shrinking and heating up, and when it reached maximum density, it bounced outward and began expanding. The Big Bang was not a beginning, it was a turnaround, and before the bounce, there was a previous universe, complete with its own stars and galaxies, contracting toward the moment of our birth. Roger Penrose, the Nobel Prize-winning physicist, has proposed an even more radical version called conformal cyclic cosmology. In his model, the universe goes through infinite cycles. Each cycle begins with a Big Bang and ends when all matter decays, all black holes evaporate, and only radiation remains. At that point, the distinction between large and small becomes meaningless, and the vast empty endpoint of one cycle becomes mathematically identical to the hot, dense starting point of the next. The death of one universe is the birth of the next, an infinite chain of cosmic reincarnation. Then there is the idea that the universe came from nothing, literally nothing. Alexander Vilenkin proposed in 1982 that the universe could have quantum tunneled into existence from a state of absolute nothingness. Not empty space, not a vacuum, nothing. No space, no time, no energy, no laws of physics. and through a quantum fluctuation, a tiny bubble of space-time appeared and began to inflate. This is possible because in quantum mechanics, the rules are different from everyday experience. Particles can appear from nothing for brief moments. Energy can be borrowed from the vacuum. And if the total energy of the universe is exactly zero, which it might be since the positive energy of matter and radiation is balanced by the negative energy of gravity, then the universe costs nothing to create. It is the ultimate free lunch. I think about this idea more than any other. A universe from nothing. No creator, no cause, no prior state. Just the laws of quantum mechanics and the fact that nothing is inherently unstable. If you have truly nothing, not even the laws of physics, then there is nothing to prevent something from appearing. Nothing is not a stable condition. Something is easier than nothing. And I do not know whether to find that terrifying or beautiful. Probably both. Stephen Hawking and James Hartle propose yet another approach, the no-boundary proposal. In their model, the universe has no boundary in time. Instead of time having a sharp starting point at the Big Bang, the Hawking-Hartle model proposes that as you approach the Big Bang, time gradually transforms into a space-like dimension. There is no edge, no first moment. Time simply smooths out and becomes something else. The way the surface of a sphere has no edge, but also has no starting point. You can walk anywhere on a sphere without ever finding a boundary. Similarly, in the Hawking-Hartle universe, you can trace time backward without ever finding a beginning. And then there is the most radical proposal of all, which comes from Alan Guth himself, the inventor of inflation, working with Sean Carroll. They suggest that the universe might be eternal in both directions, not just eternal into the future, but eternal into the past. In their model, you start with a state of maximum entropy, a kind of equilibrium, and quantum fluctuations cause pockets of low entropy to appear, each one generating an arrow of time pointing away from the equilibrium state. Our universe would be one such pocket, with time flowing in one direction, while other pockets would have time flowing in the opposite direction. There is no first moment. There is no creation event. The universe simply is, and always has been, and always will be. And this is where I have to be completely honest about the state of the science. None of these theories have been proven. None of them have been definitively ruled out. And the reason is simple. We have almost no data about what happened before inflation, because inflation destroyed the evidence. But almost no data is not the same as no data at all. And there is one fragile hope. Gravitational waves, ripples in space-time itself. If inflation occurred, it would have generated a specific pattern of gravitational waves called primordial B-mode polarization, which would leave a faint signature in the cosmic microwave background. Several experiments are searching for this signal right now. The BICEP array at the South Pole, the Simons Observatory in Chile, the upcoming LightBird satellite from Japan, and the CMB Stage 4 experiment, a massive ground-based array designed to measure the CMB with unprecedented precision. If they detect B-mode polarization, it would be the first direct evidence for cosmic inflation. It would confirm that the Big Bang was preceded by an inflationary phase, and depending on the specific characteristics of the signal, it might even help distinguish between different models of inflation, giving us our first glimpse of what came before. In 2014, a team using the BICEP 2 telescope announced they had detected B-mode polarization.
For a brief electric moment, the scientific community thought we had found it, the signal from before the Big Bang, the first direct evidence that inflation really happened. But within months, it became clear that the signal was contaminated by dust in our own galaxy. The cosmic fingerprint turned out to be a terrestrial smudge. The disappointment was enormous, but the search did not stop. It never stops. The next generation of experiments will be far more sensitive. They will be able to separate the cosmic signal from galactic foreground contamination with far greater precision. If the primordial gravitational wave signal exists at a level that current theories predict, these instruments should find it within the next decade.
And if they do, it will be one of the most important discoveries in the history of science. Not just confirmation of inflation, but our first window into whatever existed before the universe we know. But even if they succeed, they will only see the last moments of inflation, the very beginning, the trigger, the cause of inflation itself might be permanently beyond reach. Inflation is a wall between us and whatever came before. We can press our ear against the wall and listen for vibrations, but we might never see what is on the other side. And I think this is the deepest lesson of this entire subject, not the answer, but the shape of the question itself. Humans have been asking where we came from since we first developed language. Every culture on Earth has a creation story, and every creation story eventually hits the same wall. If something created the universe, what created that something? The chain of causes has to either go back forever or stop at something that has no cause. Both options are incomprehensible to a brain that evolved to track predators and find food on the African savanna. And what modern cosmology has done is not solve this problem, it has made it sharper. Inflation pushes the mystery back one step. The multiverse pushes it back further, but the fundamental question remains: why is there something rather than nothing? Why does the universe exist at all? Why are there laws of physics? Why these laws and not others? I do not have answers to these questions. I am not sure anyone ever will. But I find something deeply moving about the fact that we keep asking.
That a species of primate, living on a tiny rock orbiting an ordinary star in the suburbs of one galaxy among trillions, has figured out that the universe had a hot, dense beginning 13.8 billion years ago. That before that beginning there was likely a period of exponential inflation. That inflation may have been eternal, generating a possibly infinite multiverse of bubble universes, and that the ultimate origin of it all might be permanently, fundamentally beyond the reach of science. We are not built for these questions. Our intuition fails, our language fails, our mathematics gets us close but breaks down at the singularity. And yet we keep pushing. We build telescopes and launch them to the second Lagrange point. We construct arrays of detectors at the South Pole and in the Chilean desert. We write equations on blackboards and argue about their implications for decades. We refuse to accept that the question is unanswerable, even when the universe seems specifically designed to prevent us from answering it. And maybe that refusal is the most human thing about us. Not the ability to find answers, but the inability to stop asking the questions. The universe might have no beginning. It might have always existed in some form, inflating eternally, spawning bubble universes in an infinite cosmic foam. Or it might have tunneled into existence from absolute nothingness through a quantum fluctuation. Or it might cycle forever, each death giving birth to a new beginning.
Or time itself might simply not work the way we think it does at the boundary of existence. We do not know.
And the fact that we do not know, after centuries of science and philosophy and mathematics and telescopes and satellites and supercomputers, after all of that, the fact that we still do not know is not a failure. It is a measure of how deep the question goes. The Big Bang happened. Everything you have ever seen, touched, loved, or lost traces back to that moment. But that moment was not the beginning, it was a transition. And what came before the transition is the greatest unsolved mystery in the history of human thought. Maybe one day a detector at the South Pole will pick up the faintest whisper of primordial gravitational waves. Maybe that whisper will tell us something about inflation's beginning. Maybe it will open a crack in the wall between us and whatever came before. Or maybe the wall is permanent. Maybe the universe keeps its deepest secret forever. Maybe the question of what came before the Big Bang is the one question the universe will never answer. Either way, we will keep asking. If this video changed how you think about existence even a little, hit subscribe. We ask the questions that keep you up at night every single week. Next time, how will the universe die, and what happens after the last star burns out? See you there.